Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, my wonderful students of Senior 2. I am very excited to meet you yet for another time, another session of online TV learning. I want to welcome you so much, and I hope you're okay. Today, I am much more excited because we just finished one unit the last time we were together, and today we are going to be looking at another unit. I am your physics teacher, your physics companion, teacher JB, and I'm so excited to be with you again today. Now, today, if you come with me to the board here, we are beginning a new unit, which is unit what? Unit 6. That is what we are beginning today, Unit 6. And Unit 6 is about Pascal's Principle and its application, okay? So you need also to speak with me so you may be able to remember the name of our new unit. Pascal's Principle and its application. Now, Pascal was a certain scientist who worked so hard and came out with theories. You as a student, if you work very hard, you read, you go to university, and then you continue with your education, you never know, you might discover a principle. You might come out with a law in physics, in chemistry, in geography, any subject. So they may also honor you by giving it your name. So this is called Pascal's Principle. And also, this word disturbs people, you know, principle. We also have principle, this one. Some people confuse these two. They are not the same. This is a main. This one refers to a main. Maybe a main person, like for instance, in an institution like your school, you could be having a principal, okay, or a head teacher. So this is the chief thing, the main thing. This principle here with the PLE actually refers to a law. Okay? A law or a rule or a theorem. And so we are going to be dealing with laws. The law which was, invented by a scientist called Pascal. And also we shall be looking at its application. Now, our first lesson for today, we shall look at Pascal's principle. What does that law tell us? That's what we are going to be looking at. Okay? And so our learning objectives for today, maybe before we go to the learning objective, if you look at your screen, you are going to see we have key unit competence. I'm speaking this because we have a new unit today. So we have key unit competence, and you can see the key unit competence tells you the learner should be able to explain transmission of pressure in fluids at rest and describe its applications. So that is the key unit competence. It means throughout this unit, as we are going to be studying, that is the competence that we want you to be able to get. Okay, so going back to the lesson, it's on the board, but also it's on your screen. The lesson objectives, 1, we want you by the end of this lesson to be able to state and explain Pascal's principle of pressure transmission in a fluid. That is 1. You should be able to state that law and explain, not just stating, but explaining. Then 2, we need you to use the formula F1A2 equals F2A1. That is a beautiful formula that we have here on the board. F1A2 is equal to F2A1. And we shall see where we get that formula from. We are going to derive it together. So that is the main thing that we are going to have as our objective in this lesson. Okay? Hope you are following that. And remember, for every lesson, we have our pen, we have the notebook, so you are taking down some small notes. I also hope that you have your textbook, and then we are going to be checking, especially after this lesson, to see that we can do even more assignments, more work, more practice, and read also and get more concepts. Okay. Because it is a new unit, I'm also going to take you through the goals, unit goals. Unit goals, is like learning objectives, but which covers, the whole unit. But for learning objective like this, lesson objective, this is specific only for this lesson. So as we go through, you make sure that by the end of this unit, we are able to achieve the following goals. One, we should explain hydrostatic pressure. Here it is written static pressure. Hydrostatic pressure of fluids at rest. We should be able to explain that. But lucky enough, if you remember in Unit 5, where we are looking at measurement of liquid pressure using a manometer, we also looked at hydrostatic pressure. So you see there's a big connection. We are just going to connect them. And then 2, we should be able to explain Pascal's principle of pressure transmission. I think we are going to be able to achieve that today during our lesson. Okay? We should also be able to know the applications of Pascal's principle, that is the hydraulic press, you can see there, hydraulic brake, water towers, hydraulic jack, and so on and so forth. Okay? Applications of Pascal's principle. We may not achieve all these goals today, but by the end of this unit, we shall have succeeded in knowing them. Then we should also know that the pressure transmitted in a fluid produces a large force when a small force is applied to it. We shall succeed in doing that today. And then we should also be able to explain the functioning of the hydraulic jack, the lift pump, and then also the car brakes. So those are our unit goals. Okay? So let's go ahead. During this unit also, we are going to look at so many new words. I have not been able to show all the new words, but these are good examples of the key words that we shall encounter. So if you look at our journey from the start of our unit up to the end of the unit, the finish, you see, this green one is the finishing point. We shall be encountering words like fluids. This we looked at in Unit 5. Pressure, we looked at in previous units, including Unit 4. Hydrostatics, we also looked at that before, but we shall mention it along the way as well. Pascal's principle, we didn't see that before. We are going to talk about that today. The piston and the syringe, we are also going to look at that today. Then pressure transmission. So those are some of the key words that I would love you guys to understand as we move through this topic. This unit. Okay? Right. Let's go ahead to Pascal's principle. So what does Pascal's principle say? I want you to read it together with me, okay? So you may be able to remember. Once you say something out aloud, chances are that you can easily remember it with time. So Pascal's principle, you read together with me, says, the pressure exerted at any point in an enclosed fluid is transmitted equally throughout the whole liquid or the whole fluid. Let's repeat it one more time. The pressure exerted at any point in an enclosed fluid is transmitted equally throughout the whole liquid or the whole fluid. Now, this is what I mean. This is what Pascal's principle means. If we get a container like this, possibly made of glass, and then you create some holes on the side, okay? Create some holes on the side of this glass. So when you create some holes like this, then we shall introduce a piston. We shall introduce a piston. A piston fits directly into the mouth of this container. And I'm going to show you an example of a piston. Okay? If you look at this is an example of a piston. So let me just remove it, and try to show you what a piston is inside this syringe. Okay? I'm very sure you have seen a syringe before. Can you look at this syringe? There's this black stuff inside. You're seeing this? Inside the tube itself. It can move down or it can move up. If I apply a force here, we are going to demonstrate how it works very soon. Okay? So inside there, that is what you have as a piston. So let me first place it back, because we shall come back to this and then perform an experiment on the piston. Okay, so imagine that you place a piston, such a piston, in that container. So if the piston is there, then try to pour some water inside. Of course, when you pour some water inside, automatically water will begin coming out. So for your experiment to succeed, you may think of blocking these holes, and then you open them at the right time. So what do I want you to do here? I want you to apply a force down, okay? Like push the piston down. With some energy, of course. Now, when you push the piston down, what do you think will happen? You have applied a force on the piston. The piston, in turn, will push the water. And what will happen to the water? The water will then begin jetting out, okay? The water will begin coming out of each of these holes, like this. If you do it accurately, you'll find that the rate at which water is coming out from each of these holes is the same, okay? It will be the same. So if it is the same, it will then confirm Pascal's principle. Because in Pascal's principle, you applied your pressure at this point. Let me call this one point X. You applied your pressure at point X. That pressure is transmitted to another point, let's call it Y, and the same pressure is transmitted to another point, let's call it T, and transmitted to all these points, let me call that R, equally. So that is what Pascal's principle states. And I am challenging you, my dear students of Senior 2, you are physics students, you are very creative, you don't need this apparatus to to demonstrate Pascal's principle. You can even use a balloon. Put in water in the balloon, and then with a needle, you can punch some holes on the sides of the balloon and try to squeeze the balloon. You are going to see that water jets out in all directions. And so that is Pascal's principle. I want to take you back to our screen. Look at what we have there. The first diagram is what we have drawn there. The second diagram, someone has maybe a balloon, as I was telling you about, something round, filled with a fluid, maybe water, and then squeezed. If there are holes, you can see water is coming out from each of those holes. And so same rate, it means the pressure is the same. Look at the third diagram right here, where you're applying an effort. Effort is the force that you apply. The load is what you want to overcome. Okay? If you want to lift something, that becomes the load. And we are going to look at that here. And then this is very similar to the diagram that we have already seen there. So that is Pascal's principle. I hope you have followed that. Now, during this unit, we are going to learn very interesting concepts, which is used, everywhere. You go to cars, you will find these principles being used. We shall discover how is Pascal's principle used in the car, but you will find it is there. If you go to a lift, you will find it there, if you know what a lift is. If you go to, brakes, the brakes of a car, or the brakes of a motorcycle, Pascal's principle is used there, and in so many areas. And we shall be able to, I hope, create certain devices that work basing on Pascal's principle. And I will be challenging you every time we come for this lesson. Okay? Get ready to have lots of creations, just like I'm going to do as well. Okay. So let us now demonstrate Pascal's principle using syringes and delivery tubes. Okay? Let's demonstrate that. And you can also do this at home. Very possible. If you go back to school, yes, you will be able to do it as well. So this is my retort stand. This is the clamp. So we have 2 retort stands. And this is a delivery tube. You see? This one is a delivery tube. If you don't have it at home, you could get this from a pharmacy. Okay? Pharmacists have it. You buy a tube together with this, the connecting tube. This is a syringe together. And then you can just put them together. Me, I looked for a device that can allow me to connect this tube to the next syringe. Quite easily done like that. And so, this is my load. I have put a lot of luggage inside there. Let me add some more luggage inside. Huh? This is something very heavy. Of course, heavy in quotes. You see? I'm adding more load, a lot of stuff. But of course, this principle is what then we shall see is used in cars. Okay? But this is a small apparatus. We cannot bring a very heavy load. So we are starting with something which is light. But it's the same principle which is used in cars. You get that? Okay. So this tube has got a smaller diameter compared to this. This is smaller and this is bigger. So does it compare with this? This is the smaller tube and this is the bigger tube. You see? It should compare with this. On top of the bigger tube, I have put a load. On top of this bigger tube, I have put a load. Okay? For me, let me put a car. Okay? Let me put a car there. Okay. Just imagine, but somehow we have put a car there. And this is what I'm talking about. You saw me adding some loads here. Now, if I apply a force, F1, on this piston, the first piston, we are having A1. This A1 is equal to area of the small piston. Okay? A2 is the area of the what? The big piston. Everybody can see that A2 is greater than what? A1. Force F1 is a force applied on the small piston. So my question is, and my challenge to you is, if we apply a force F1 on this small piston, what do you think will happen to this load? Think about it. What do you think will happen to the load according to Pascal's principle? Think about it. Okay? Me already have my answer. I want to believe you also have your answer. So let me stand here and then we demonstrate and see. Okay? I'm going to push this one down. That is, I'm applying F1. Okay? Observe carefully and see. Do you see anything happening to the load? Do you see what is happening to the load? Me, I did. The load went up. I applied the force here. This load has gone up. The other big piston has gone up. What does it mean? There was also a force which was being applied on what? On A2. So what does it mean? The pressure which was here was transmitted equally throughout this liquid and then came and acted on this big piston. And that is the magic. Just think about it. That is the magic. What about if I push this one down? What do you think will happen? The big piston, push it down. What will happen to the small piston? Okay, let us see what happens. Push it down. Look at what is happening to the small piston. Push this one down. Look at what happens to the big piston. That's wonderful. That force can do a lot of work. If I pull this one up, you look at what is happening to the big piston. It goes down. That is wonderful. And we are going to have so many projects on that. Some of them we might be able to execute them here. Others you may be able to do them at home. Okay. So let's move ahead. So the pressure produced by the small piston, remember pressure is equal to force divided by what? By area. And so the force here is F1, the area there is A1. Let's look at the pressure here. The pressure here is going to be equal to F2 divided by what? A2. So this pressure here, let me call this one P1, and this is P2. P1 is the pressure here, and P2 is the pressure there. But we are saying the pressure is transmitted equally throughout the whole liquid. So what does it mean? It therefore means that P1 is equal to P what? Is equal to P2. And if P1 is equal to P2, it therefore means that F1 over A1 is equal to F2 over A2. Do you get that? Because the two pressures are the same. So here, instead of even calling P1 or P2, we can just call P, we can call it P. So everywhere here, we have the same pressure. And that's what we're talking about. So we equate this to the other one. And when you cross-multiply here, we then have F1 times A2 is equal to F2 times A1. Okay? When you cross-multiply, isn't that what we get? This is what we get. And that is a beautiful formula that we said we should be able to derive. And do what? And use it. And so we have derived that formula, and we are going to use it. So look at our diagram there. You have got a car which is being raised using, you have got a car which is being raised using the hydraulic machine, okay? So same idea here. Let's move ahead. Look at those formulas. All the formulas you're seeing there on the board, on the screen, is what we have been deriving here, all of them. But what I've done is I've just stated them in different ways. I hope you are able to see the formula very well. F1 over A1 equals F2 over A2, and so on and so forth. Okay? Pressure is force over area, and all the other formulas. Okay? So let's look at one quick example before we can finish our lesson. So the example is, look at the diagram. Look at the diagram. We are using the same principle that we have derived from here. You remember the formulas that we looked at? Let me just take you back to that formula. Some people may have forgotten. Look at that wonderful formula. We have so many of them. F1 over A1, which is this one, is equal to F2 over A2. We looked at that. Cross-multiplying, this is what we get. But remember, F1 is a force on the small piston, and F2 is a force on the big piston. A1, small area of the small piston, and A2 is area of the big piston. Okay? So remember that formula. Quite very easy. And so let's go ahead and look at our sample question. Okay. Read the question. Read the question. I'm not going to read out the question for you because it is on the screen. You are able to see it very well. Read the question and understand. So the question is saying, a force of 10 newtons applied on the small piston. So the force here, remember we call it F1, is equal to 10 newtons. Is applied on the small piston whose area is given as 20 centimeters squared. Okay? The small piston is connected to the large piston by means of a fluid, like we have there. And they are asking us to calculate the pressure exerted in the fluid. Okay? That is part one. They want us to get the pressure exerted in the fluid. Then part B, what force is exerted on the large piston? Remember, this is A2, and the force here is F2. But area of the large piston is given as 200 centimeters squared. So let's begin with the pressure. Pressure is equal to force divided by what? By area, which is going to be equal to 10 newtons divided by 20 centimeters squared. And our pressure, if you cross out that, we have 1 over 2. And 1 over 2 is the same as 0.5 newtons per what? Per centimeter squared. Now, newtons per centimeter squared is not the standard unit of pressure, but you can express it that way, no problem. Newtons per centimeters squared. Let's go to the second one. Second one, they want us to get F2. Remember, we said pressure is equal to F2 over what? A2. Cross multiply. When you cross multiply, F2 is going to be equal to pressure, then times what? A2. But it is the same pressure. So this gives you 0.5 times A2, which is what? 200. This is 0.5 newtons, and this is 200 centimeters squared. So no problem. If you multiply that, I'm sure you are going to come out with what? 100 newtons. And so that becomes the value of F2, which is the force on the what? On the large piston. So as we summarize our lesson, I'm very sure we have been able to meet our learning objectives, stating and explaining Pascal's principle of pressure transmission, and also using the formula F1A2 equals F2A1. I'm now going to leave you with the assignment, as you can see on the screen. Go through it very well and get the answers. So thank you so much for being good students. Continue attending all the lessons, and I know you are going to increase in wisdom. So the question says, define the term fluid, that is part A. Part B, state Pascal's principle of pressure transmission. Then part C, a force F is applied onto the small piston. So there's a force on the small piston. The area of the small piston is 0.05 square meter. So they have given you this area. And that of the big piston is 0.75. They have also given you this. So what are they asking us to do? If the force exerted on the big piston, the force exerted on the big piston is also given. So they want us to get F what? They want us to get F1. So thank you for being nice students. Continue being safe and enjoy all the rest of the lessons on TV. Till we meet again next time, bye-bye.